Everyone, I'm Shenlong. In this project, I focus on two questions. What factors affect a student's final math grade, grade 3, and can we group students into different performance profiles? I used the UCI and Kaggle student performance dataset. The math dataset has 395 records, and after merging it with the Portuguese dataset, the total is 1,044 records, which meets the coursework requirement. For posting, I first checked missing values, all were zero. Then I converted key variables or numeric and finally applied standardization for clustering. We'll show three core visualizations. The first is the correlations heat map. It shows failures and grade 3 are natively correlated around minus 0.36. Grade 2 and grade 3 are very strongly correlated around 0.91. The second is the regression scatters plot of failures with grade 3. The trend line clearly slope downward, meaning more past failures are generally linked to lower final grade. Third is the distributions of grade 3. The average is about 10.42, with most students in the middle range, but there is still noticeable variation. I used the linear regression with study time, failures, absence, module, and value to predict grade 3. The result was sequence equal to 0.053 and remers equal to 4.41. And the key result is that failures has a coefficient of about minus 2.11, which is the strongest negative effect in the model. Then I applied the k-means, clusterings, and select k equal to 3. The clusters are easy to interpret. One group has high grades and few failures. One group has low grade and many failures, which is at risk group. The one middle performing group has relatively higher absence. Overall, the main takeaway is past failures are constantly associated with lower performance, and clusterings reveal clear students' profiles. As for limitations, this is observational data, so we can't claim causalities, and the regressions exploratories power is relatively low. For future work, I would include more features and try stronger low linear model to improve performance. Watching.